When I joined the industry, I realized industry can do a lot that academia cannot do. Because academia, you are in the constraints of the organization and funding. But industry, you have a crazy idea, you can go look for venture capitalists. You can form a whole new organism in a sense, right? And then you can pick a direction. That's kind of my journey. And I fall in love with building new companies because new company is like a baby.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, how to live a longer, healthier life. We are produced by Inside Tracker, your science-based guide to optimize your body from the inside out. Our guest today is Dr. Wei-Wu. He is a pioneering scientist, inventor, entrepreneur, and biotech investor with more than 3 decades of leadership at the forefront of genomics and precision medicine. He currently serves as an executive chairman of the Human Longevity Inc. HLI, where he is advancing bold mission to transform healthcare from reactive to proactive by leveraging whole genome sequencing, advanced imaging, liquid biopsy, multi-omics, and AI to detect diseases early and extend human health span. Dr. Wei-Wu is involved in many biotech and pharma companies and a general partner of Emerging Technology Partners, a life science venture fund established in 2000 that has supported more than 60 biotech startups. Earlier in his career, he was among the first scientists at Human Genomic Sciences, worked alongside Craig Venter, and previously conducted research at Massachusetts General Hospital and the Mayo Clinic. With over 90 scientific publications and more than 32 issues patent, Dr. He has made significant contribution to molecular biology, protein and antibody engineering, DNA RNA technologies, and development of therapeutics targeting aging-related diseases, including Alzheimer's, Parkinson, arthritis, and tissue repair. Under his leadership, Human Longevity Incorporated has grown into a global precision medicine platform with clinics in San Diego, San Francisco, and Beijing, and expansion underway across multiple countries. His work reflects a singular vision. The most chronic diseases and many premature diseases are preventable with today's technology. Dr. He held a PhD in molecular biology from Baylor College of Medicine and an MBA from the Wharton School. Welcome, Dr. He.
Thank you so much.
You're welcome. And before we will start, I would like to remind our listener that if you are enjoying Longevity by Design, please like and follow the podcast on Apple Podcasts, Spotify, and YouTube, so you don't miss any future episode. So I would like to start by your scientific journey. And as I said in the introduction, you had an amazing journey across biotech, diagnostic, and many other endeavors, including the full genome sequencing together with a celebrity, at least for me, Craig Venter, and so on. So can you share to our audience how you first become interested in biomarkers and precision medicine?
Yeah, no, this is great, Gail. Actually, my journey, is a lot longer than my scientific journey. And I, did some reflection, why I'm so addicted to this field. I probably trace back to, my, around 6, 7 years old, because I grew up with my grandmother. So my mom was not, was a professor, and she was sent to the countryside during the Cultural Revolution in China. So my grandmother is my mother because, and she's probably the most loving human being I can recollect in my brand. She probably will take a bullet for me. Okay. Unfortunately, at the 63, she had a bleeding and she went to the hospital, never came back. And she died literally at the 63 of a very late stage cervical cancer. So I think that had a tremendous impact on a 60-year-old kid because, how can you, most loving human being, went to the hospital, never came back, what's wrong? She looks very healthy, right? So, and she's very robust, lady. I think that's really, triggered my curiosity of, of this whole field because, people don't believe me that I've been interested in longevity for more than 50 years. Okay, but when you look at Tiger Woods, he played golf. He always say when the moment his father put a golf club in his hand at 4 years old, he got addicted. Okay, so I got addicted. To answer the question why a seemingly healthy 64-year-old can drop dead in 2 months, right? That's really so when I went to college, although I did it well in math and physics, I didn't go study math and physics. I went to the biochemistry department in Nanjing University and eventually followed a professor, Dr. Zheng Ji, and he's a very famous professor in China. He studies longevity, nutritional science. He lived to 110. Okay. So when I was his graduate student, he was already 85 years old. I was his last graduate student at 85. And he always bragged to us that he's going to live over 100. So he kind of did an N-of-1 study, experiment on himself. He actually wrote a book. It's called The Wisdom of Living Longer. Long. I think he finished his last edition at 108 years old. That's his last edition. So in his book, his number one proposal in his book is you have to achieve metabolic balance and emotional balance. These are the two things he thinks is most important. Metabolic balance is food, exercise, and sleep. And then obviously emotional balance is don't care too much about money, fame, and all that. Okay, so you have to live yourself, achieve your inner peace, and which is easy to say, difficult to do, right? So obviously, and he's the one encouraged me to come to the U.S. I came to the U.S. to do my PhD at Baylor. I was involved in early on cloning a gene called PSA. Prostate specific antigen. That's actually my paper ever. The first paper in my entire life is the cloning the PSA and studying the expression of PSA in prostate. It's a very interesting subject. Then I followed my mentor to Mayo Clinic for a few years, Mass General for a few years. I was always curious about how to detect the cancer, early cancer. So we were working on ovarian cancer detection at Mass General. And then, when Craig, called me in 1992 to join the first large-scale DNA sequencing company, Human Genome Sciences, I visited it and they already bought 100 sequencing machine. This is like, as a postdoc, I have never seen it. I mean, it's like 100 sequencing machine, At our time in 1992, you clone one gene, you get your PhD, right? And you do some functional experiment, you clone one gene, you do some functional experiment, you get your PhD. But, Craig was sequencing like thousands of EST, gene fragment a day, okay, or a week, I kind of can feel this is a revolution coming. So I joined HGS, and then, it's like a stem cell. When I joined the industry, I realized industry can do a lot that academia cannot do. Because academia, you are in the constraints of the organization and funding. But industry, you have a crazy idea, you can go look for venture capitalists. You can form a whole new organism in a sense, right? And then you can pick a direction. That's kind of my journey. And I fall in love with building new companies because new company is like a baby. You can pick your direction. And for instance, we invested in a company called Banyan. We got the first traumatic brain injury marker ever approved by FDA in human history. So FDA before TBI test never approved any blood marker in the brain, until 2018 Valentine's Day. Finally, we had two markers. It's a GFAP and UCHL1. Those two markers can, using blood, you can detect if somebody has TBI, traumatic brain injury, which is now, GFAP is also a biomarker for Alzheimer's now. And it was so hard to get the first approval. It's a de novo approval. So I've been working on a lot of these technology. And so when I went to see Craig 10 years ago, when Craig talked about human longevity, it's the next chapter of decoding the human genome. I kind of fall in love and I got involved. Now I've been involved with human longevity for 10 years. And I think this is an amazing platform to deliver the next generation medicine to delay age-related chronic diseases, because we need to understand our genome. We need to understand our phenotype. So it's how do we connect the genotype with phenotype? That's really the next chapter of human biology.
Yeah. Thank you so much for the great introduction. And just for our audience, Craig Venter is the person that actually, it's not alone, but with his company, he basically sequenced the first full human genome. And there was a race between him, a small company, versus all the NIH with billions of dollars. And I think that you can tell us more, Dr. Wei-Wu, how much it cost him. But I think that it was like 10 times or maybe 100 times less than what the NIH spent, correct?
Yeah. So basically, you have to believe in technology innovation, right? So Craig used a technology called shotgun. The government was actually sequencing the genome by allocating each chromosome. So say UMass, WashU will get a particular chromosome, Baylor will get a particular chromosome, Stanford will get a chromosome. So everybody's walking on the chromosome. So Craig basically say, why bother? Let's just break the entire genome into pieces, right? 300 base pair, 500 base pair. You just sequence them and use computer, because if you have overlap, you know which piece sticks to where, right? And you use shotgun. And he experimented, the shotgun sequencing with bacterial genome, then it's Drosophila genome, then it's mouse genome, and just Drosophila genome. Then he basically say, let's just use shotgun genome sequencing to decode the human genome. So he raised probably about $200 million. The U.S. government spent, the government, UK, German government, everybody chipped in. It's about $3 billion. So it turned out to be the shotgun sequencing actually works. And so there's a story about, the famous Nobel laureate, Hamilton Smith. By the way, Mr. Smith just passed away a few weeks ago, 2 weeks ago. And Craig wrote a very, very nice paper about him in Nature, I think last week. Ham being a Nobel Prize laureate, when Craig say, let's go sequence the human genome, which is very risky. If they declare they're going to do it, if it fails, it's a pretty big failure. And Ham basically said, let's do it. Okay, so I'm with you. Even if it fails, we're with you. I mean, this is basically the moonshot initiative, just like, Elon Musk trying to send recyclable, space shuttle. I think this is, the human spirit. We're willing to take the risk and move forward and move the science forward, right? So that's really the essence. I think the Human Longevity Inc. is really Craig's vision of the post-genome sequencing initiative. How do we find, genes like, BRCA1, BRCA2, or these monogenic disease genes to link it with phenotype? In this case, BRCA1, the phenotype is breast cancer and ovarian cancer, right? How do we do it at a large scale, right? So that's really because that's really matters for human health. Yeah. Because every one of us is predisposed to some high risk There's 50,000 human disease names by WHO. Okay, so, every one of us has some high risk for something.
Yeah.
My AI scientist predicted, my biggest risk is stroke. And by the way, my dad died of stroke at 88. So the question is, how can I, outlive my dad maybe by 12, 13 years? So I'll be living over 100 without a stroke. So I have 30 some years to prevent it. So the question is, can I do it? So I believe I can. so right.
Yeah. So going back to human genome sequencing, so that's happened around year 2000 or so.
25 years ago. And it cost $3 billion. Today, the best quote I got is $100.
Exactly. That's what I wanted to say, that 25 years ago, it cost, you said 300, 200 million. It doesn't matter. Now it's at $100. So you can see how technology like that, or how innovation like what Craig Venter invented or used, changed completely the world, that today everyone can sequence the genome by spending $100 or $200, and then you have all the wealth of information of that. And I'm sure that we'll discuss what can you do with that later. My follow-up question to you is, it sounds like you came to, if I recall correctly, to Baylor and sequenced the PSA. And PSA is a prostate-specific antigen.
We were one of the group actually, found the PSA gene. Yeah.
And PSA, it's one of a best marker for prostate cancer that still today every male or almost every male are testing. Obviously, it's not 100% accurate, but it's pretty good to give you some knowledge about whether you have a prostate cancer currently in your body or not. And my question to you is, was the Aurora moment for you to come and say, biomarker is how can we, that's the tool that we'll use in order to extend the health span, or was it another Aurora moment?
Oh, it's, because I kind of, by then, I already know biomarker is extremely valuable for cancer detection because, the early cancer detection for for cervical cancer is Pap smear, right? Pap smear has been around for so long. Now, I wish my grandmother did a Pap smear like 5 years before she died, right? So she probably wouldn't die at the age of 63 if she did a Pap smear. But at that time, China was so poor, nobody does Pap smear. And so I had a hunch. So, when my mentor handed me the project to clone PSA, I was very excited, because there were, at the time, there's already, the PSA gene is very interesting. It's the protein was discovered first before the gene was cloned. Okay. So, I think a scientist, a Taiwanese scientist, injected a prostate lysate into a rabbit. And then they use the polyclonal antibody from the rabbit to do a Western blot, and they see one band only specific to prostate. That's why they call it PSA, prostate-specific antigen, right? So, and there was a lot of study at the protein level, but the gene was never cloned until 1986. So I was very interested in that. So, but PSA, believe it or not, is a very lousy marker. I think the positive predictive value for age, 55 is, I think it's like 50%. In today's standard, it's really horrible. It's like today's camera is what, the 40 megapixel. When I bought my first Sony digital camera, it was like 0.6 megapixel. Okay, it was still like $400 like 20 years ago, okay, or 30 years ago, right? So the technology has improved so much. PSA is still useful because it's so easy to, so cheap and so easy to monitor. But if you combine genetics, polygenic risk score plus PSA, other biomarker plus imaging, your positive predictive value, I think it could be more than, we think our algorithm is more than 90% positive predictive value for stage 2 prostate cancer.
Wow.
And stage 1 or stage 2. So you technically shouldn't miss a stage 3 prostate cancer anymore.
Yeah.
So this is why human, go ahead.
So question about that, sorry to interrupt. So there is a very famous person right now that was detected with prostate cancer. Is the former President Biden. How do you explain that they haven't?
Well, they claim, I don't know what it, the U.S. current guideline is, I think after 72, you don't need to do a PSA, right? But that's based on statistics. Okay, so this is really I think there's two defined. One is a statistic medicine. One is individualized, personalized medicine, right? So, the PSA test, I think it's less than probably $20 in the Quest diagnostic panel. The total panel is only $400. So PSA is one of the, hundreds of protein you measure. The question is, why do you want to save $10 for the president? And follow the medical guidelines. So I don't get it. But I think he get a pretty late stage. I think it's Gleason 8 or Gleason 9. Don't quote me on that. That's pretty late stage prostate cancer that you miss. So because if you did a MRI, you wouldn't miss it, right? If you did so we actually combine genomic information, polygenic risk score, and I can elaborate on that. If you are the top 10 percentile of polygenic risk score for prostate cancer, you contribute to 20% of the deaths in the future. So if you're the top 10 percentile, if you're born with the top 10 percentile, prostate cancer polygenic risk score, about 130 genes contribute to that.
Yeah.
So if you are the top 10 percentile, you are going to be the top. The 20% of people who will get prostate cancer 60, 70 years from now, right? And then if you follow PSA and you follow imaging, you can't really miss it, in today's technology under human longevity's platform. This is the platform we are actually building. It's a holistic, it's a symphony. I always say longevity care is a symphony. It's not a one piecemeal. Right. So there's a lot of companies say, if you did a whole body MRI, you won't get cancer, which is not true. It's like somebody says, my violin is so good, I can play, Beethoven 9 symphony, right? So one violin can never conduct the Beethoven 9 in the holistic, sense, right? So,
I see it as a multifactorial problem, and we are. In my opinion, we are the most complex machine that was developed ever. And because of that, I agree with you 1%. You need to look in a different layers and try to overlay them in order to understand. So I agree with you 1%. One follow-up question that I have that you mentioned, and I think that it will be good for our listener to understand, is a Pap smear. Can you explain what is a Pap smear and what is used for?
Basically, you took a cervical, scrap, and you put it onto a glass slide, and you look under the microscope, and the structure of there's a cancer cell in the cervical epithelium in the microscope look differently. It was developed by this famous doctor. I can't pronounce his last, Greek last name. We call it Pap. Okay, Pap smear. He invented, the Dr. Pap invented the Pap smear. Basically, you should, scrape some epithelium from the cervical sample and put it on a piece of glass and look under the microscope, right? Yeah. And then later on, there's a company created a much easier to read called SimPrep. As you can see the tumor cell much better than the traditional Pap smear. So SimPrep, today I think every women past certain age they probably do one, right? Yeah. And now you have molecular testing like HPV, because later on the Nobel Prize was given to the discovery of HPV, and we now know that HPV is a real cause of cervical cancer.
Yeah, and now there is actually immunization that develoned by a company named Merck that you can, that basically, if it was going back to your grandma, if it was, I don't know, 50 years ago, maybe she will be saved by this.
Die at 63, right? So for sure.
So that's again an amazing, I think, a personal story that combined with the development of the science and the technology in the world. That a Pap smear and correct me if I'm wrong, for me Pap smear is like the PSA for males, and
Oh,
something.
absolutely. Yes, yes.
And it's something that every woman should do it, as you said, several times in her lifetime. And but more than that, for that, we even found that it's most of the cancer created by virus. So now you can have immunize the women, and actually
Absolutely.
some of us even saying that you should inject it also for male to in order to protect their partner. And it's very interesting how we progress. And I think that that's a good example of one kind of cancer that it's
Yes.
more or less under control because of the advance in a human in technology, in biological technology.
Well, liver cancer is another one because most liver cancer in Asia is caused by hepatitis B infection.
Mm-hmm.
So in the US, the kids is born, you get a hepatitis B, vaccine right away.
Yeah.
So in developed nation, has early hepatitis B vaccine, the liver cancer rate is very low now. Now in the US, liver cancer is going up. It's mostly because of fatty liver and liver cirrhosis. So it's a different cause,
Yeah.
But in Asia, I think in China, 500,000 people die of liver cancer every year, but it's
Wow.
mostly because of hepatitis B.
Wow.
So the biology is already understood, but it's just, even cervical cancer. In the US, I think cervical cancer in the last 50 years has dropped by 80%, 70-80% death rate is dropped, right? So by cervical cancer, but globally, there's more than 300,000 women dies every year of cervical cancer as of today.
And that's because they don't have access to the vaccine?
Vaccine and the screening,
Okay.
or they don't screen. In the US, actually, the people get cervical cancer are the group of people living in certain area. They never go see a doctor, right?
Yeah.
So, and then if they get infected, the only time they find out they have it is, they feel pain, right? So they feel pain, or there's already late phenotype, right? So this is actually what, I always talk as a venture capitalist. Usually, there is actually a light bulb, in a scientist. I just had Dr. Mike Levitt, in my house. So we had a very interesting conversation. He got the Nobel.
Actually, I've seen him a few weeks ago. Yeah.
Oh, really? Okay.
Yeah.
So he basically say, he's the one came up with the idea that computer, algorithm can predict macromolecule structure, right?
Yeah.
But he got his Nobel Prize 44 years after he published the paper, right? And now finally, with AlphaFold and all that, so it's becoming a more accepted, AlphaFold even got the Nobel Prize last year, right? So, I mean, from a light bulb, come out to people understand it, people understand it. That's the next phase. And then humanity take action that 8 billion people actually will have access to it. That takes a long time in medicine.
Yeah.
For instance, if genome sequencing comes down to $100, in my opinion, there's no reason why 8 billion people don't do a whole genome sequencing.
Correct.
Because for $100, if you live 100 years, it's $1 a year, okay? Everybody can afford it. I think even the people in the poorest country can afford it, okay?
So let's discuss that. That's a very good point. So let's assume that every person in the world will sequence his genome. What will be the value? I think that it's good for our audience to understand from someone like yourself that have a lot of expertise. You have been in the team that sequenced the first human in the world. So what will be the value? Let's assume that a person, one of our listeners, will go and sequence the genome, full sequencing. What will be the value for him as of today?
Yeah. Okay. So scientifically, we call it the extreme genome risk is obviously monogenic genetic disease, right? So, U.S. government already does it for PKU. PKU is a genetic disease. When the baby is born, they take some blood from your heel and, detect a gene called PKU. Because if the kids are born with PKU, a monogenic genetic disease, if you don't care about the protein intake, the kid will become very low IQ. And, so can't even graduate from high school. Now, if you understood the kid has PKU, you just need to change a protein diet. One of my physician's son has PKU, and he went to Stanford. Okay, so so that means he's super smart, with PKU. But you have to understand, PKU, the monogenic genetic disease, is a great example. Is food is medicine, but it's personalized. Okay, so because if you have a mutation, one single nucleotide mutation on PKU, you cannot take certain amino acid because your body doesn't know how to metabolize it. So if you take those amino acid, you will have low IQ. It will cause neuronal damage. But mutation like PKU, there's about 10,000 of them. There's sickle cell anemia, beta thalassemia, cystic fibrosis, Duchenne muscular dystrophy, Parkinson. I mean, there's 10,000 of them. Okay, I'm sure the U.S. government today is paying probably $50 for PKU test. Okay, it's mandatory when your baby is born. It's mandatory. The government covers it. But for $100, it covers 10,000 PKU type of mutation. To me, as a scientist, that's no brainer.
So one value is at the moment that our son or daughter will be born, we know exactly what out of the 10,000 monogenic diseases they are actually predisposed to. That's one, correct?
Yeah, basically, it's pathological monogenic disease, like BRCA1. BRCA1, Angelina Jolie has a BRCA1. Now, the phenotype is breast cancer and ovarian cancer probably 56 years from the birth.
Yeah.
You're not going to get ovarian cancer and breast cancer overnight, right? So it's going to take, the phenotype will take 50 years to develop.
Yeah.
But we know that, for Angelina Jolie, because her mother has it, so the phenotype happens in her family, right?
Yeah.
So we know with probably about 80% probability, she will get breast cancer before the age of around 60. Okay, so that's called a phenotype. And that phenotype calculation is based on the family history. Now, if you have a BRCA1 mutation, your family never has the history. It's only 15, 20%. Okay, so, but if you have the mutation, your family has a phenotype, that means there's no other compensatory genes to cover the risk of BRCA1. There are people carry BRCA1 mutation, but they have other genes to compensate it, and they only have 10% risk, right? So this is really what I come down to, what we call polygenic risk score. So when you're born, for prostate cancer, for instance, we take 130 genes to calculate your polygenic risk score for prostate cancer, right? So that's really so every human being when they're born is a bell curve. So there are people who are the top 10 percentile for prostate cancer. Then there are people who are the bottom 10%, right? So and that algorithm has to improve over time. Because, Johns Hopkins just discovered a brand new prostate cancer gene. It's a very long name. I forgot the name, but Dr. Isaac actually discovered it this year. And it was discovered out of all the Ashkenazi Jew population who got prostate cancer. So this gene actually has a founder effect. Somehow this gene was actually, more prominent in the Ashkenazi Jew population. So when we took that mutation, searched our 10,000 database, we find 7 people carry that gene, 4 men and 3 women. And the 4 men, out of 4 men, 3 of them has Ashkenazi Jew last name. Yeah. Okay. So we don't know what is the other man, because the other man looks like a Scandinavian last name, but he could be, his father could have married a Jewish.
Yeah, it could be a mix. Mixed.
And then we have 3 ladies actually carry the mutation. Now, this gene, according to the paper by Dr. Isaac from Hopkins, is as bad as BRCA2. So for that 7 people, the knowledge of their prostate cancer was just discovered this year.
Yeah.
We didn't have that knowledge last year, right?
Yeah.
So the genomic knowledge is an ongoing genotype, phenotype journey for the next 50, 100 years, right? So people think, oh, I sequence your genome, I already understand everything you have. That's a lie. Okay, we human beings only understand so little about our genome. So last time I talked to Craig think we human beings at the most understand 5% of medically related genomic information.
Yeah.
Right?
And
Like,
again, if I'm trying to summarize it for our listener and great information that you provide, so basically you sequence your genome, you have immediately access to around 10,000 monogenic gene, meaning that one mutation can cause something specific, some disease. And then you have polygenic, basically looking at a different location in the DNA. You gave the example of a risk score for prostate cancer that you look at 130 specific single nucleotide polymorphism or SNP in different locations, that based on that you can give a risk score for a person, whether he have a very high risk or very low risk for prostate cancer. And how many of those do we have today? Is it hundreds of polygenic score for a disease?
For prostate cancer, we use about 130. Okay.
Yeah.
At least for the Caucasian population, because it turned out to be the study in China is totally different. Okay. And for polygenic risk score. So there's a kind of a race-specific polygenic risk score. Like, you probably have to create a polygenic risk score for Ashkenazi Jews, okay? Because, their genetics is a little bit, like this particular gene discovered this year for prostate cancer is very prominent in Ashkenazi Jew population. It's a stop codon in one of the copy. So it's a dominant mutation. So if the other gene has a stop codon, you're dead. Okay, so probably. So you wouldn't survive. But if you have one copy had a stop codon, you have high incidence of prostate cancer, right? So WHO has 50,000 names for a disease, okay? 50,000. So I guarantee you, every one of us, Guy, or you probably have a top 10 percentile polygenic risk score for one of these 50,000 diseases. Okay, and the question is, do you want to know? For Engineer Julie, does she want to know I have a BRCA1 mutation, right?
Yeah.
For instance, I have a polygenic risk score of high stroke. Do I want to know? And now my father has died of, a stroke. He had hypertension and all that, but when he had hypertension in his 30s, but at that time, he doesn't even have access to medicine, right, to reduce hypertension. But he still survived to 88 years old. So that means I probably have a decent chance of beat that number. Knowingly at age 60, I already know I have a high risk for stroke. So everybody has because everybody is a unique machine at the genomic level.
Yeah. Going back to your point about the $100 investment. So I'm going back to that. So we have 10,000 monogenic diseases that we already know, and we can give the user some information about that. And then what you are saying, there are 50,000 other diseases that most likely will be polygenic. And we cannot give the information for all the 50,000 diseases yet, but every year or every few months, there is a new development, like what you mentioned about the prostate cancer, that we will start knowing more and more about those diseases. So that's why it's a good investment to sequence your genome, because it's all the time there is an update. Like in the computer software, you have an update. You have an update in your genetic information. Come say, hey, Moses, we detect that you might have a high risk for this disease. Go and do those tests to confirm or basically be sure that you don't have it right now.
It's a bell curve. Okay, so because you look at people like George Byrne, he smoked cigar until 100 years old. Yeah. So my gut feeling is his polygenic risk score for cancer is probably the bottom 10%.
Yeah.
So we are actually sequencing a lot of centenarian genome and a super centenarian genome. So if you become a centenarian or a super centenarian, by definition, you didn't die of cancer. Okay? Yeah. So you are like the bald-headed whale. The bald-headed whale, can live to 200 years old and never actually get cancer, right? So So if you are a super centenarian like a Maria, the genome sequencing was just published this year. If you have, 5,000 super centenarian or a few super centenarian, their genome is probably the bottom 10 percentile for cancer risk. Okay.
Yeah.
So in the future, if I sequence your genome, Gil, I already know, say, is your genome look like President Biden, or your genome look like a super centenarian? Okay, so that's all right. Because that information is all AI, right? Because it's trillions of data. You basically, who do you look like? Okay, so right.
Yeah.
Do you look like a super centenarian, or do you look like somebody has a cystic fibrosis? Okay,
Yeah.
so right.
Yeah, and that reminds me a story from Nir Barzilai. I'm sure that you know Nir Barzilai is one of the leader in aging research, and
he's an amazing scientist. Yeah,
and he has a cohort of I think 500 centenarian that most of them are Ashkenazi Jew. And he also tell the story about a lady that he come to visit her, and she is 105, and he see her smoking. And he tell her, hey, miss, don't you know that smoking is bad? Nobody told you that? And she replied to him and said, yeah, the four doctors that I had told me that smoking is bad, but all of them are dead, and I'm still alive. So
this is what George Burns said. Okay. My point is, she probably has the ball-headed whale genome. Okay?
Yeah.
And you can do whatever you want. The DNA fatality. Right now, cancer seems to be, the consensus scientifically is you have DNA repair, DNA fatality issue. The naked mole rat has a gene, it's a helicase, right? So, the claim is, if you have these high fidelity, DNA repair versus, the ball-headed whale, they credited a gene called CGAS, right? So these genes, when they inject these genes to the Drosophila or the fruit fly lives, longer, right? So we human being probably is a spectrum. You have one spectrum which people carries mutation like BRCA1, BRCA2, P53 mutation. They have lousy DNA checkpoint and DNA fidelity. And then you have people like George Burns and people like Maria, is a Spanish lady, lived to 117. They probably have almost like the naked mole rat gene or the ball-headed whale gene. So they can do a lot of damage. They still don't get cancer, right? So the question is, you as one of the 8 billion people, do you want to know which where are you on that bell curve, right?
Yeah.
I want to know.
Yeah. And I think that what I'm taking from that discussion, and correct me if I'm wrong, is if you are a gifted person, such of, the 500 super centenarian that are around, you don't need genetics. You know that you are great. But most of us are not a part of those 500 centenarian or super centenarian.
But they know that afterwards, right? So
but if you have a family, like we know that it's very genetic. So if my father lived to 110, most likely that I will live to that age. So those are the.
Not true. That's scientifically not true, because you only got 50% of your father's gene. Okay.
Correct.
Because you don't know this is what we don't know, the random combination of 23 chromosomes.
Yeah, that's correct.
It's almost like a shuffling. Okay.
Yeah. So my argument was
management in venture. When you hire two really smart guys working together, they may actually destroy the company. Okay.
Yeah. So let me adjust my argument, because you're right.
Yeah.
But let's assume that you are centenarian and you are above 100. You don't need to do that DNA test. But I would say 99.999% of us are not centenarian and don't have such an amazing genes. So doing the sequencing will give us so much information about all the diseases and also all the polygenic risk score that will provide to us a lot of value today, but in 5 or 10 years, it will be even a much, much higher value. So it's a great investment for everyone.
I think for major diseases, the day is already come.
Yeah.
Today, because of heart attack risk, stroke risk, cardiovascular. So let me give you I always give an analogy of Titanic, the boat, right? So that boat is perfectly fine. except they hit an iceberg. Okay, so you can have a perfect body, but if 200 years ago you got smallpox, okay, you die. Okay, your body is totally fine. Your father gave you centenarian genome, but you hit an iceberg. In that case, is smallpox. And most people don't realize in the last two centuries, the smallpox vaccine was already invented. Because I think the smallpox vaccine was invented in 1790. Okay. 1 billion people died of smallpox in the last 2 centuries. 1 billion. 1 billion. Okay. Until WHO claimed to eradicate smallpox around 1980. Right? So in that 200 years, 1 billion people die. They should not have to, okay, because their body is perfectly fine. They have a boat of Titanic, except they jam into an iceberg called a smallpox. But the same analogy holds true today. From today, if we don't change the cancer prevention protocol today, how many people will die in the next 100 years? Do you know?
I don't. Well, how many?
If you ask ChatGPT, it's 1 to 2 billion.
Wow.
Because globally today, 10 million people die every year of cancer. 10 million every year. 100 years, if nothing changes, that's 1 billion. But now the world population is aging. So there's more and more old people. So they projected by 2050, there will be 18 million people die of cancer every year if we don't change anything. So in the next 100 years, if we don't change the protocol of cancer prevention, about 2 billion people will die in the next 100 years. That will be more people get killed by every single war in the human history, okay? All the war combined, we don't kill 2 billion people, okay? But meanwhile, we are complacent. We don't really, but the technology is here. This is why I'm so anxious when I talk about this, because my grandmother doesn't need to die. Okay, so the biology is already here. The platform to predict somebody's cancer is already here. This is why human longevity, we put $1 million pledge for cancer. We're about to add another cancer, colon cancer. If you become our member, because we deliver a totally different, algorithm and platform. If you get a stage 4 prostate cancer, for instance, or stage 4 ovarian cancer, we missed it. And we will commit $1 million to treat you, because we will bring you to NCI or Hopkins, or we will help you find, cell therapy treatment and all that. That $1 million is on us, okay? Because I have confidence that we will not miss a stage 4 prostate cancer patient. The technology is already here. It's just like if you had a pap smear, HPV testing, and vaccine, your odds of dying from cervical cancer is so low, right? Yeah. You shouldn't, because, it's like today you take the smallpox vaccine, you shouldn't die of smallpox.
Yeah, absolutely.
Right? So 2 billion, think about that number, 2 billion people will die of cancer in the next 100 years. Yeah. Now, the Achilles heel for cancer is early detection. It's just like iceberg, for Titanic. If you knew the iceberg, an hour ahead of time, says there's an iceberg will kill you, because you put a radar or GPS or, whatever the signal, and you have an hour to navigate your boat to avoid that iceberg, would you do it? Or you just say, I don't care. I'm just going to jam into the iceberg. Some boats don't jam into iceberg, even in the winter. They get lucky. Okay, people like George Byrne or Aeneas, late 105. They're lucky because they didn't in their whole life they didn't jam into a iceberg. So 2 billion people will do in the next 100 years. Okay, so do you want to buy a radar? Okay, so right?
Yeah, no, I hear you, and I think that it's a very good argument. And we spent a lot of time, which was great, on genomic genetics and trying to understand the basic genetic risk score. which is good. And I think that it was a very refreshing, at least to me, and I hope for our audience to understand what can we learn from that. And it's look like we can learn a lot. But today we have several other tools that allow us to early detect cancer. So maybe let's name them, and if you can elaborate a bit about what is the value of each of them.
Oh, this is great. So I'll take, prostate cancer, because I researched prostate cancer for 40 years now. Okay, so, so it's because to me, I think right now, 50,000 American dies every year of prostate cancer. Okay, the death rate is already much lower today. Okay, because of early detection, probably some credit will go to PSA, right? So, but PSA being not very specific and sensitive, it probably have, over alert a lot of people, right? So creates unnecessary needle biopsy and all that. But that's, but still, the death rate in the US is coming down. 50,000 right now. Every year, 50,000 American male die of prostate cancer. The question is, how do we drop that by 90%? As a prostate cancer researcher, I'm 100% convinced we can drop at least 80, 90%.
What would you do?
You need to understand your polygenic risk score.
Okay.
Because there's monogenic risk score, which is much rare. It's like maybe 5%. People has a gene BRCA2. If you have BRCA2, ATM, or the Lynch syndrome gene, like the DNA repair mutation, and now there's this Hopkins gene for Ashkenazi Jews, and there's another gene called HOXB13. So people who has HOXB13, their prostate cancer grow very aggressively. So you need to understand these genetic factor. If I tell anybody carry HOXB13 to be extremely careful with your prostate, because if you do have it, the general consensus is prostate cancer grows slowly, but not for the prostate cancer people who carries HOXB13, okay?
Yeah.
That's a totally different population. This is why personalized medicine is so important. Then you have to understand your polygenic risk score. So people like George Byrne probably is in the bottom 10 percentile of the polygenic risk score. So, I always say, what is polygenic risk score? I use the analogy. So if you are the captain of Titanic and you are leaving London in the summer, in the hot summer, you probably do not need to worry about iceberg, because there's no iceberg in the ocean. It's the summer. so right. So your polygenic risk score is like summer. You are so low. Your odds of hitting an iceberg is almost zero, because there's no iceberg, because it's summer. Now, if you leave London in the middle of the coldest winter, okay, now there's an iceberg. Okay, and you have to be careful. Okay, so this is really genome actually will add so much value to. So when company like there's a lot of companies say, oh, just do a 1.5T whole body MRI will solve all the cancer problem. That's not true, because a whole body MRI will miss a lot of information. It's a symphony.
Can you describe what does it mean, all body MRI? What is the test?
Basically, we use the most advanced software and the best machine. We use a Siemens Vita, right? So we scan, from your head to toe, right? And we build a specific cancer detection algorithm. We work with Anders Dale. He's probably one of the most famous scientists in this area. So he has a software called ISI. You can pick out, the high water content, out of very small tumor cells. So when you scan it, you probably won't miss like prostate cancer. You won't miss like, I think even for ovarian cancer or that, you can see it, right? Or bladder cancer, or pancreatic cancer. So you can see it. We detected quite a few of these cancer patients at very early stage. If you go to our website, there's a, Mr. Kim, Adelson, we detected his pancreatic cancer early. He's totally cancer-free, 4 or 5 years later. And he went to Mass General, operated by Dr. Keith Lillimore, the former chief of surgery of Mass General. and did such a good surgery that, he's totally cancer free, right? So, and he's, he has a YouTube video for us. So, so I'm not disclosing any private.
And
personal.
what is the size of the cancer that
Depends.
advanced imaging can detect? What is the smallest size?
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At Inside Tracker, we take a personalized approach to Healthspan optimization that eliminates guesswork from your wellness plan. Inside Tracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the Inside Tracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
We actually, for certain cancer, we can detect 0.2 centimeter.
Okay.
So 2 millimeter, right?
2 millimeter, okay.
Yeah, so it's very small because, for liver cancer, for instance, it typically has to grow to 5-6 centimeter to kill you, which is big, right? So, but 0.2 centimeter is very small, right? So especially if you use contrast MRI, right? So, we're trying to avoid contrast MRI. But, we're starting to work with company. This is actually Mike Levy's, stepson. Actually, he built a company in Israel. There's a particular dye, only lasts in your body for, 5 minutes. So you create that dye, inject it into yourself. They think they can detect the cancer at 0.1 centimeter.
Yeah.
Yeah. So with all these technology are coming. Okay. So let me go back. We use Genome because it's getting cheaper and cheaper, and you only need to do once in your lifetime, or But I don't want to go to the detail because right now, if you talk to Dr. Craig Venter, he thinks that the current genome is not good enough because you don't do wrong reads. You will miss all the inversion or repeat sequence, right?
Yeah.
So this is why we're talking about the telomere to telomere sequencing, which is still very expensive, probably still costs thousands of dollars. But if people are willing to spend thousands of dollars, you can do telomere to telomere sequencing, long read sequencing, which is probably even have more information.
Yeah.
So you do the sequencing.
So that's
Right.
where they are doing it with a nanopore, like
we use Illumina. We use Illumina sequencing.
No, but for the long read, you can use the Illumina.
You use nanopore, or you have to use PacBio.
Okay.
So then you combine that with Illumina sequencing,
Okay.
right? So you do a much more holistic.
Yeah. So Dr. Wei-Wu, I just want to try to see that I understand, and hopefully our listener understand. So we spoke a lot about genetics and sequencing, and that can give you diseases that are monogenic and also polygenic. Then we discussed a bit about advanced imaging. And I know that there is another tool that came recently called liquid biopsy that is also. Can you describe what does it mean? What is liquid biopsy?
Oh, it's basically, when you have a tumor growing in your body, tumor cells in general grow faster and they go through apoptosis faster. Right. So, or the necrosis or apoptosis, and they will shed, tumor DNA into your bloodstream. Right. So, through the, maybe sometimes it's the shedding of the membrane particle of the tumor cell. They will have DNA in there and they will circulate it in your blood. Okay. Right. Because the sequencing technology is so much better today. You can do like a 10x sequencing. You can do 30,000 X sequencing. I can do 1,000,000 X sequencing if I wanted to see if I have any rare mutation in my blood, right? So, there's a company like Grail, Exact Science, Cologuard. These are all my definition of liquid biopsy. So they are basically trying to detect aberration in your DNA, methylation. We work with a company called, Clear Note. And they use a form of methylation called a 5-hydroxyl methylation. So for that particular methylation, it seems to me it's much more accurate for pancreatic cancer and ovarian cancer. So we adopt, this test is called Avon-Tech pancreatic cancer, Avon-Tech ovarian cancer. When I look at the data, it's amazing. The negative predictive value for Avon-Tech pancreatic cancer is 99.6%. So meaning if you test negative, you're 99.6%, you don't have stage 3 pancreatic cancer, right? So something like that, which is, I never seen it before I've been working on diagnostic marker, for 40 years. I always say the holy grail of diagnostic is 100% specific and 100% sensitive, right? So if there's one such thing, we will cure cancer because it's 100%. Yeah.
Can you explain to our audience what is specificity and so on?
Oh, specificity, let's say you have 10,000 people.
Okay.
And there's 5 people out of 10,000, has already stage 1 prostate cancer. And your test can actually detect all 5 of them. That's called sensitivity, right? You didn't miss anybody. Right?
Yeah.
But specificity is how many people do you have to accuse they have prostate cancer to detect those 5?
Yeah.
Now, if your specificity is 100%, you only accuse 5 people.
Yeah.
It's like
the right 5 people. So it's basically false positive. It's basically false positive, false negative, correct?
It's basically 0 false positive and 0 false negative. That's called 100%.
Yeah.
Okay.
Yeah.
But for cancer, because cancer is so complex, everybody's mutation is different. Everybody's genomic background is different. Different people eat different food, different, stress level and all that. The biology of cancer is so complex. It's much more complex than cardiovascular disease. So we picked the cancer because cancer by definition is the most complex diseases, in terms of genomic changes and biology, right? So, so you can have 2 parents their whole family never had a cancer, but suddenly one baby has cancer. Okay, so, right. The question is why? We don't know. Maybe it's a different combination of genome and So let's coming back. So so we are basically for instance, our prostate cancer algorithm today using genetics, proteomics, metabolomics, and imaging, and a ctDNA, it's probably the last data I looked at, our AUC, area under curve, is 0.9, which basically is very high. PSA is 0.5. Okay, so I don't want to get into the scientific jargon. Basically AUC 1.0 means 100 sensitivity, 100 specificity. Okay.
So you are in the 90%, more or less.
Yeah. We're almost there. Okay.
Yeah.
We're almost there. But now if you do longitudinal assay, like say, Gil, you come to our clinic for 10 years in a row. I have your changing data, okay? Your PSA changing data, your imaging changing data, and all your liquid biopsy changing data. I think, I can probably bet you, Gil, if you're under my care, I can guarantee you'd never die from prostate cancer.
Yeah. So in a way, what if I'm trying to summarize, what you are saying that in the human longevity, you are using different kind of detection for cancer, different kind of tools. And because you are using all of them together, it's much better than someone that's just going and doing imaging, or someone that's just looking at the genomics, or someone that's just doing the liquid biopsy, because you basically overlay them together, and then the combination of all together is much better than each of them separately. That's correct?
Yeah, so I'll give you one case. Okay, so there's a lady came into our clinic in San Francisco recently. Okay, but she has been a member of us for probably 2 or 3 years. So she actually tests positive on Cologuard. Cologuard is for colon cancer. So our physician basically eventually convinced somebody, at Stanford to do a colonoscopy. Initially, the doctor is refusing, as they said, there's so much false positive for Cologuard. You probably be fine, okay. But, and she insisted, our client insisted. But the colonoscopy come back negative. Okay. And then the doctor says, I told you, you have no problem, right? So, but then we did grill test for her. It turned out to be positive again. Okay. So you have Grail positive, Cologuard positive, but colonoscopy negative.
Just one comment. Grail is the liquid biopsy for our audience.
Grail is a liquid biopsy. It's we use them. We are also using Exact Science. We use a lot of things. We don't favor a particular one, but I'm just giving you this one particular case. The fact we use Grail, the Cologuard. So our doctor, is very inquisitive, and he basically got into this community of doctors, basically ask the question, basically using AI, open evidence and all that. If a client that get tested positive for Grail and for Cologuard, but it's colonoscopy negative, what should we do? And one doctor said, you need to check appendix, because the traditional colonoscopy don't check appendix. Lo and behold, she has a stage 3 appendix cancer, and it's almost ready to metastasize. So if she don't do anything, 2 to 3 years from now, we probably will have a case of metastasized appendix cancer, which is a kind of a cul-de-sac of colon, right?
Yeah.
Because most of the colonoscopy don't stick a probe into the appendix to look if there's anything there. It's not the standard protocol. But this is a case. This case actually made my day. Okay, so I just really get so excited. That means, we saved her life because we use this integrated approach for her. And for me is, if we can save one cancer patient, I don't even take a salary at the Human Longevity. This is my hobby job. Okay, so if we can save one lady like this, this makes my day. Okay.
Yeah.
So the challenge is, can we take this holistic platform and to prevent the next billion cancer deaths in the next 100 years, right? So that's really the ultimate holy grail. That can we deliver that?
Yeah.
In my opinion, we should. We actually should be able to deliver that.
Yeah.
To save at least 1 billion people alive in the next 100 years. Basically, to save 1 billion Titanic hitting an iceberg. Right? In this particular case, this lady already have a cancer iceberg. It's appendix cancer, not colon cancer, but this appendix cancer can be picked out by Cologuard and Grail.
Yeah. I think that was a great example of how the multi-diagnostic tools can actually augment each other and give you an hint of what to do, and one tool can always miss something. So that's why it's good to use multi of them. So that's great, and thank you so much for that in so much detail. And I want to move to the next part of the discussion, and that's basically a quick fire round. And I will ask a quick question, and I'm asking for a quick answer for them. The first one is, can you name one biomarker you check most often for your own health? What would it be?
If I have to pick one?
Yes.
But it's only because I already know my my kind of a winter or summer risk. Okay, so because I already know I have cardiovascular risk, so the stroke, right? So if there's one, I right now use CGM. Okay.
CGM.
Because I'm already, so 10 years ago when I invested in Human Longevity, the first checkup I had is, my BMI was like 26. Okay, so 27. My liver fat, it was like 10%. Okay, so my hemoglobin A1C, which is the diabetic number, is 6.4. It's on the borderline of a full-blown diabetes. And so ever since I put a CGM on, I realized, I was eating some food is really bad for me. Okay, so I love ice cream, but ice cream always spike my sugar big time. I like to eat rice, in the morning, which always spikes my sugar big time. So I changed my behavior. I lost 30 pounds. So my liver fat now is 1%. So I reversed my hemoglobin A1C to 5.4.
Wow.
But unfortunately, my metabolic machine is already probably pre-diabetic. So I'm much more resistant to insulin, basically. So my 60-year-old machine is already not like a 20-year-old machine. So I know that. Okay, so I religiously monitor my glucose level.
Okay.
So I realized, because it changes my behavior, because I used to eat very fast. If I eat very fast, like I eat a bowl of noodle very fast, my glucose will go to like 250, 300, right? But if I eat it slowly, I eat a bowl of noodle like in 20 minutes, my sugar will go to 150. It will never go beyond 200. So for me to control my blood sugar level is probably a longevity intervention for me, okay? So different people are different. This is why, if for me, glucose level, LDL level, make sure my blood vessel can last over 100 years is my top number one priority. Exercise, to make sure my blood vessel is functional. So I don't want to create these sugar spike to kill my micro blood vessel, basically, right? So that's for me. Different people are different. If somebody is, born with PKU, they need to manage their protein, amino acid toxicity, right? So that's, different. For Angelina Jolie, she has the BRCA1 mutation. If there's one test, she needs to do to live over 100, she needs to make sure she doesn't die of breast cancer and ovarian cancer.
Yeah.
Right. So that's, that's my answer for you. So, yeah. So it's personalized, basically.
No, absolutely. And the next question is, the daily habit you think is underrated for longevity?
Daily? Well, I think exercise, sleep, and, nutrition is, my mentor lived to 110. He basically, he's lucky he didn't get cancer, right? So he sailed his boat for 110 years. He didn't hit an iceberg. But there's an element of luck in there. And obviously, probably his genome is pretty good for cancer, right? So, but then he really believed in, mental calmness. Basically, don't create cortisol, because if you are always have anxiety, your probably cortisol level is too high. It's probably bad for your blood vessel and the immune system. And then you sleep well, eat well, and exercise. I think exercise is by far the most important for health span. Because I would rather drop dead at 90 years old, but totally functional. I can pick up my grandson and I can play golf. I can swim, at 99 and 90 something, like Charlie Munger, right? So I call it Charlie Munger, health span. You're still paying tax. You're not a burden for society. You're not a burden for kids. And you drop dead, because your body is still functional. Instead of you get Alzheimer's or dementia, lying in the bed for 20 years, and your kids has to come visit you, you are a burden to society. So in that case, with that goal in mind, exercise is so important. You want to make sure your body is, functional. Your brain is, your mind is active, right? So if your body is in good shape, but your mind is in good shape, you're halfway there. so right.
Excellent.
So,
and one longevity myth you wish would disappear?
It's everybody is selling one thing for longevity. Okay, somebody say, "Oh, my olive oil is better than everybody's olive oil," or some people say, "Oh, if you just did a 1.5 T whole body MRI will cure cancer." I wish this would disappear, because there's no one violin can play the holistic longevity medicine. Okay, because every human being wants to do simplified. They want one solution to live to 100. I don't think there's such a thing, because every one of us is different. Your parents gave you 6 different billing codes. Okay, Gail, your 6 billing code is slightly different from my 6 billing code. Okay, so everybody's different. I think the revolution of decoding the genome, and with all these more sensitive, for instance, we're embracing Tony Viscori's protein age clock, right? Because, most people don't die of old age like my mentor lived to under 10. They die of an iceberg. Like Steve Jobs, he died of a pancreatic cancer iceberg. right? The Intel CEO died of a prostate cancer iceberg. So we don't, there's two aspects of longevity medicine. One is just don't die of smallpox, don't die of cancer, don't die of a heart attack, don't die of. So because 90% of Americans today get killed by top 10 causes, right? 90%, cardiovascular disease and cancer kills half of Americans every year, right? So two major diseases.
Yeah.
And these are totally delayable. I wouldn't say 100% preventable, because by the time you're 110 years old, it's, you already reached to your design age of our human genome. Then we need a stem cell to extend our body, right? So, so one myth is, don't believe in anything, which people sell you one thing can add 20, 30, 100 years to your life, because every one of us is an individualized, unique machine.
Yeah, makes sense. And if the listener would like to remember just one idea from our conversation today, what should it be?
Oh, you need to embrace today's technology. So I think today's longevity science, I call it longevity science. I couldn't find any better name for it, because unfortunately, term longevity has been overused by snake oil salespeople, or everybody uses longevity. I call it scientific longevity.
Yeah.
It's data-driven longevity, right? So people need to embrace that, and they need to use AI, because using your own data. Let's say, Gil, you come to our clinic for 5 times, in the next 5 years. We have terabytes of data on you. And you have AI for that terabytes of data. And you can use that data to compare to the latest New England Journal of Medicine paper. So we are creating that AI just for you, okay, with a terabytes of data on you. Then you should become the CEO of your house.
Yeah.
Because nobody cares about your body than yourself. I don't even think the best physician in the world, they're busy.
Yeah.
They have to take care of hundreds and thousands of people. They are never going to care about your body more than you care about your body. So today, the revolution is AI and data. So with high quality data and high quality AI, medical grade AI, you will become the CEO of your own body. And the AI will teach you how to become your best doctor, okay? You will know who to call, okay? If today I have a late-stage cervical cancer patient, I will call Steve, Rothenberg at NCI, because there's actually T cell to treat late-stage cervical cancer. And Steve Rothenberg is doing it at the NCI. And the AI will tell you that. If you have the last result, what do? Go call Steve Rothenberg, Dr. Steve Rothenberg. Okay, so right? You become the CEO of your own house. I think that's the revolution. It's coming.
Yeah.
When I had dinner with Dr. Hinton, he got the Nobel Prize last year. We believe the conversation after 3 hours is we believe we need to have 50,000, specialized AI for 50,000 human diseases. So for prostate cancer, you need an AlphaGo. I don't know how many people know about AlphaGo, or AlphaFold. You need an AlphaFold, AlphaGo algorithm just for prostate cancer, because the data set to train that algorithm is very different than breast cancer, right? Right. So, and the environmental change is different, because the American diet versus Japanese diet has a huge difference on prostate cancer outcome. So, whether you take red meat or not, it has a huge outcome. So eventually with AI, you become your own personalized precision medicine physician for your own longevity. That's my advice to everybody.
Okay.
Everybody should learn the knowledge of your own body as if you are addicted to a video game or addicted to something you really love. Okay, but that's your body. Your body is the most valuable asset of your whole life.
Yeah.
You need to own the knowledge of your body.
Okay, so thank you so much, Dr. Wei-Wu, for joining us today and sharing your insight on biomarkers, AI, and the future of precision health. Your work continue to advance the field and help us understand the path toward a longer, healthier life. So again, thank you so much. And for our audience, if you enjoyed today's episode of Longevity by Design, please follow the podcast on Apple Podcasts, Spotify, and YouTube. Leave us a rating and review. It's to help others discover this conversation about science, health, and longevity. Thanks again for tuning to Longevity by Design, produced by Insight Tracker. We'll see you next time.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Insight Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out, using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcasts.